Hello and welcome back, everyone. In this video, where we're going to talk about controllers, we are on chapter 2 of module 3. And we've already seen what an Arduino is. And this chapter is going to be about controllers. We're going to see what all controllers are there and how do you classify a controller. Now, when I talk about controllers, I mostly talk about algorithm-based controllers. I'm not talking about hardware-based controllers. So make sure that you understand that. It's very important. Okay, so without any further ado, let's actually dive into it and see what I'm talking. Okay, so over here we have the controller chapter, and we're going to start with it. And let's move ahead. So controllers are components, okay, used to regulate the behavior of robotic systems. Majorly regarding the processes. If you remember Arduino is also a controller. Okay, so you need to understand that Arduino is a physical controller. Okay, which means it's a microcontroller. It's not a microprocessor. Very important, microcontroller. Okay, and Arduino on one side basically allows you to make sure that all the processes are done in the way they are supposed to done. Okay, so supposed to be done. So Arduino is like one of the most fundamental controller that you'll ever find in the market. Very important. And controllers receive input from sensors and other sources, and they use that information to determine the appropriate action for the robot to take. Okay, basically what all action you want to take is basically defined by the controller, and that's very important. There are several types of controller which are used in robotics, including proportional integral derivative (PID) controller. Okay, now this is a software-based controller, which is important. Okay, now PID controllers are used when you want to have a lot of sensor data, and when you want to fuse the sensor data into one single solution. I'll tell you a very simple example. Let's say you are running. Okay, at that time, your smartwatch has a GPS. Smartwatch has an accelerometer, gyroscope, which calculates your speed and acceleration. Then you have the GPS on your phone, which figures out your location. And then using all this data, you get a map on the phone, which tells you at what point in this when you were running, you were running at the fastest and where you were running the slowest. Okay, this is wholly determined because of the PID controller, and this is what is very important. That you need to understand that all of these controllers allow you to figure out which action has been taking place and how do you resolve it. Okay. Now then you have model predictive controller or MPC controllers used in mathematical model for system to predict its behavior and calculate appropriate control action. Okay. Now system behavior prediction means that you want to figure out how the system is going to behave next. Okay. Now this prediction systems allow you to already stop if there's any mishappening which is going to happen. Okay. An MPC controller or model predictive controller is one of the most fundamental controllers which is used in automotive industry. Okay. Usually when you have ABS, okay, or when you have any sort of accidents which are happening, model predictive controller is the logic behind, figuring out if there's going to be an accident or not. Okay. Now, all of those cases where, you have autonomous cars, NPC controllers are the ones which are going to be used for making sure that the vehicle stops at the right time. Okay. If you don't have NPC controllers, then chances of getting hit are going to be very high. And then chances of getting damage are going to be very high as well. So MPC are like one of those controllers which make sure that the vehicle is not getting hit to anyone. Very important controllers, highly in demand. Okay, so if you're someone who is just new to the market, I would highly recommend just checking them out and be sure what they are up to, because it's pretty important these days. Okay. Then you have fuzzy logic controllers. Okay, fuzzy logic controllers are use linguistic variables to represent the inputs and the outputs of the control system, allowing more flexible and intuitive control. Now, fuzzy logic basically means that you are building an algorithm or you are building a logic system which uses linguistic variables. Linguistic variables means next, okay, forward, backward. All of these words which are there, okay, you might be coming across a fuzzy logic controller in robotics where you have NLP, okay, natural language processing. Let's say a lot of you must have heard about ChatGPT. It uses something known as large language model, LLM. Okay, so essentially speaking, fuzzy logic controllers, when combined in huge volume, basically makes an LLM model. Okay, so ChatGPT also consists of something like a fuzzy logic controller, which allows for linguistic words to be computed and linguistic words to help give a conclusion at the end. Very important. Then you have controllers are important in robotics because they enable robots to perform tasks in precise and controlled manner. Of course, I mean, if you want a robot to go from your bedroom to kitchen, there should be a controller that can handle all these processes and make sure that the robot actually goes from point A to point B. If there is no controller which is going to do this, then it's going to be impossible for you to do any operation which you want to do. Then you have controller provide the robot with the ability of responding to changes in the environment and adjusting its behavior accordingly. Okay, system adjustment is such an important thing in robotics. Okay, the way your system behaves and the way your system works is gonna allow your robot to understand and move according to what you want. So if you don't have like this sort of provision, or if you don't have the controller which can do this, then I think that's a very limiting task, because otherwise if you cannot adjust to the environment, then your robot is going to work only for one environment properly, and otherwise it's going to just fail and fail and fail all the time, and that's something that you don't really want in your robot to be there. Okay, and you can avoid it with the help of something like this, which is going to be like a controller. Okay, a controller that can help you predict, maintain, and also take actions accordingly. If there are no action which are taken accordingly, then chances of system failure are really high. Okay, and when we say system failure, for small robot it might be a small failure, but with huge robots it can be a very big challenge. Okay, and you always want to avoid it, okay, with the help of better controllers. And this is something which is going to be like one of those areas which are going to be there. And then you have example of such controllers. Okay, such some of the examples include a PID controller for regulating the speed and position of robotic joints. Now, robotic joints basically means robotic arms or robotic dogs, where you have a lot of joints and controllers, and you want to regulate the speed of all these joints and controllers. One of the way you can do that is with the help of this PID control. Okay, this not only allows you to build a solid robust algorithm, but also helps you build a solid robust way of tuning these processes as well. Okay, then you have MPC controllers, okay, which are used in trajectory of a robotic arm. Now, I already told you model predictive controllers also used in autonomous vehicles, where the vehicle or where the car is moving autonomously, and you don't want the car to fail. MPC controllers are brilliant for that. Okay, they can really work hard and predict all the future outcomes, and can save your vehicle and also the robot if you are working with one. Okay, very important. Fuzzy logics controllers are control behaving of autonomous vehicles. Of course, fuzzy logics are also used in autonomous vehicles. Why? Because whenever you have a conclusive decision that you have to make, should I move left or should I move right or should I go straight? All of these, options which are there are very easily resolved if you have a fuzzy logic controller. Okay, so fuzzy logic, as we talked about earlier as well, it's a more linguistic based model which allows you to, linguistically figure out and estimate, which option is the best option for your current situation. In conclusion, you have controllers which are essential for robotics, enabling robots and platforms, to take and task and in a precise manner, and perform tasks in a very precise manner as well. These are several type of controller, including PID controller, MPC, fuzzy logic, with that we talked about. Okay, understanding these different type of controllers and their application is essential for designing, building an effective robotic system. Now, before I say that we are, one thing which is very important is that you should know that whenever you are working with any sort of model predictive or any sort of controller that is there, one of the most important thing that we don't really talk about is tuning, system tuning. Okay, now whenever you have a controller, system tuning is the process by which that controller adapts according to your system. Now, for that you need a lot of maths that usually comes from something known as a kinematic equation or the model equations. Now, once you have a model, okay, like a mathematical model of your entire system, then you can tune all these values and tune all the system that you have, and then predict all these values in a much more better way. If you don't have effective values, then it's going to be a little more challenging to predict all these results and conclude something. Now, when I say conclude something, it also means that you would want to make sure that you are you are figuring out your initial estimates, your final estimates, and you are having the ground truth reality. What does that mean? That means the present state, the past state, and future state is going to be estimated with the help of a controller. Okay, it can be a PID controller, it can be a FPC controller, and all of these controllers help you design and figure out all of these estimates. Now, the way and the reason why I'm telling you and emphasizing on all these things is because of the fact that, let's say hypothetically speaking, you're not sure which controller you want to work on. The easiest way to decide which controller is going to work for you is to start with PID. Okay, PID controllers are 95% applicable to all sorts of application. Rest of the application might require an MPC controller, okay, a fuzzy logic controller, but 95% of them, PID works really well. Okay, from my experiences, I have seen PID works really well, and almost everywhere you can put a PID controller and you're sorted. Okay, PID controller also is complemented with something known as a Kalman filter or Kalman filter. So Kalman filter is essentially a tuning filter which allows you to, figure out a good estimate of the accurate results. Now, and a Kalman filter with a PID is sole bread and butter for 99%, I think 95% of claim or use cases that you want to be seeing. Okay. Be it sensors, be it robotic locomotion, be it any other thing you want to work on. And these are like very effectively used. So I hope you understood all of these things. I hope you understood this entire chapter. I'll see you all in the next one. Till then, happy learning and peace.